Okay, so now we're going to be factoring, again, trinomials, 3 terms, but we're now going to get rid of the restriction that this first number here has to be a 1. Okay, it could be a 1, but it doesn't have to be anymore. Right? So we're going to be factoring trinomials of the form ax squared plus bx plus c, although it doesn't have to be an x, right? So it could be a y or a u or an a or something else, right? Some other letter. Right. So the method we're going to use here is called the AC method. Right. And the reason why it's called the AC method is that the first step is to multiply A times C. Right. But before we talk about the AC method, we're going to talk about the method that we skipped here. Right. We're skipping the section that has to do with the guess and check method. And the reason why we're skipping it is because it's essentially redundant, right? It does the same thing as the AC method. And in my opinion, the AC method is actually better than the guess and check method. Again, that's just my opinion. And for those of you that like the guess and check method, well, I'm not going to stop you from doing it that way as long as you show your work, right? In other words, you show all your guesses, right? And you show all your checks, right? Check everything and show everything, then I'll be okay with that. But for most of you, I would prefer you just forget this method entirely, right? Skip it entirely. And if you did learn it in the past, you really should forget it. It's not a great way to do this, right? The AC method is far better. Okay? But again, if you do the guess and check method, at least show your work. I'd prefer you just forget it entirely. Okay? So yeah, we're going to use the AC method here to factor these trinomials rather than the guess and check method. I mean, I will say the guess and check method might be better in some cases, or it might be faster in some cases, but in other cases it's way worse and much slower. So, right. So again, I think the AC method works a lot better here. Now the AC method is right. It's more steps. So let's go through it step by step here. And I'm going to do it by just looking at an example. And I got to make sure I have enough space here. Right? So let's suppose we want to factor 2x squared plus 11x plus 5. Okay? So notice that here a is 2, right? B is 11, and C is 5. Right? And so the GCF is 1. Right? Because 11 and 5 are not divisible by 2, we cannot factor out a 2 here. Right? Okay. So yeah, that's something we did in the previous video. Right? Okay. So the first step in the AC method is we're going to multiply A times C. Okay, so that's usually pretty easy. A times C here is 2 times 5, and 2 times 5 is 10. Okay. Step 2. We need to find two numbers, right, whose product is this number, A times C, in this case 10, right? And whose sum, when you add them, you want to get B. Right? In this case, B is 11. Okay, so yeah, this should not be too hard. What two numbers multiply to 10, right? That's the product, and have a sum of 11. Well, let's start with the obvious one. 1 times 10 is 10. And 1 plus 10 is 11. right? So that works. We got it on the first try here, right? Okay. Now, here's where the AC method gets a little bit trickier, right? Because we're not done yet. Right? Step 3 is to split the middle term here, right? That's the b times x, into the sum from part 2, right? In the previous step, right? The sum that we got in step 2. Okay? So what do I mean by that, right? So here's our step 3. The middle term here, right, is not 11, it's 11 times x. But we can split 11 times x as 1 times x plus 10 times x, right? Because 1 plus 10 is 11, so 1x plus 10x is 11x. Agreed? Okay. Now, we're going to do that with the 11x here. So don't forget, we still have the original problem was 2x squared plus 11x plus 5. Okay. So we're going to break apart the 11x. We'll still keep the 2x squared, but the 11x will now be written as positive 1x plus 10x plus 5. Okay. So that's our step 3 here, right? So one more, well, 2 more steps actually, but we'll just call it one more step, right? Step 4 is to now factor by grouping, right? And that was a couple of videos ago, but hopefully you remember how to factor by grouping, right? So what do we need? We need 4 terms. So if you notice, the original problem here, right, the 2x squared plus 11x plus 5, that was a trinomial. That only had 3 terms. So this third step here was necessary. We had to break apart the 11x into the 1x plus 10x so that now we have our 4 terms. Right? So this has 4 terms. So now we can factor by grouping. And that's step 4, right? And that is the last step, right? After that, we're done. So remember how grouping works. We're going to split this up, take the first 2 terms here, and then the last 2 terms here, right? So what's the GCF out of just the first 2 terms? Right? The 2 and the 1 just give you a 1, but they both have an x. So we can factor out the x, leaving us with 2x plus 1. Okay. What about the last 2 terms? 10 and 5, the GCF is a 5. So when you divide by 5, you get 2x plus 1. Well, we have our perfect match here, right? The 2x plus 1 is our common factor. Right? So let's factor out the 2x plus 1. And when you factor out the 2x plus 1, you multiply by x plus 5. And guess what? We're done. That's all we had to do, right? So yes, could you have gotten this by guessing and checking? Probably. And probably a lot faster than the way I did it here. But keep in mind that I'm going through this slowly here. I'm going through this step by step as our first example. I'll call it example 1, right? And we'll see other problems where, doing it the other way might not be as easy. And so using the AC method will always get you the answer, right? Now keep in mind that in step 2 here, what if we don't find 2 numbers whose sum is b? Right? If there are no such numbers, then we can stop right there and say that it's prime, right? Or at least that part of it is prime. Okay, but that didn't happen here, right? And it usually won't happen, but we've seen in the previous video that that can happen, right? So, all right. So we'll use the AC method. We'll just do it with a different example. Okay, so AC method again. This time we want to factor 10x squared plus 19x plus 6. Okay, so again, just make sure you factor out the GCF first. In this case, it's a 1, so we can skip that step. Right, now we recognize that A is 10, B is 19, and C is 6. So step 1, what's A times C? 10 times 6, right, which is 60. Okay, so step 2, so this is usually the hard part here, right? We have to find two numbers so that the product is equal to 60 and then the sum is equal to 19. Okay, now they're both positive, so let's start with the obvious 1 and 60. 1 times 60 is 60, but 1 plus 60 is 61, which is not a match, right? We're looking for 19 here, right? So let's go on to the next combination. How about 2 times 30? Well, 2 plus 30 is 32, still no match. How about 3 times 20, right? And this looks familiar because I know we've done 60 before. Right, so 3 plus 20 is 23, which is not 19. It is close, but it's got to be a perfect match. Okay, what if we divide by 4? 60 divided by 4 is 15. Okay, so 4 times 15 is 60, and 4 plus 15 is 19. And that's what we wanted. So that's our match, right? So it's not prime. Okay, all right, step 3. So remember step 3, I'm going to write down the original problem, 10x squared plus 19x plus 6. And step 3 is to split up the middle term here, the 19x, into the sum that we got from the previous step. The sum is 4 plus 15. Right, so that's going to be 4x plus 15x. Okay. Now don't forget, we still have the 10x squared in front and the 6 in the back at the end. All right, so that's step 3. Step 4, well, we have 4 terms now, so we can factor by grouping. So remember, we just split this up in the middle here. We factor the first 2 terms by factoring out the GCF. The GCF in this case, 2x, right? And when you divide 10x squared by 2x, you just get 5x. 4x divided by 2x is 2. Right? And you can check. If you multiply this out, you get 10x squared plus 4x, which is what we had up here, right? All right, but I need some space for that. We'll come back to that. And now we do the last 2 terms here, the 15x plus the 6. What's the GCF here? Oops, sorry about that. That's going to be a 3. 15x divided by 3 is 5x. 6 divided by 3 is 2. And we can see we have the 5x plus 2 is our common factor here. So one more thing to do, factor out the 5x plus 2, and it multiplies the 2x plus the 3, right? So 2x plus 3. And we're done. Right, so that's the answer. Right, remember, the order doesn't matter, so if you got 2x plus 3 times 5x plus 2, congratulations. You got it right. Same order, I mean, right, different order, just doesn't matter. And this is what you would get if you split up the sum in the opposite order here. Right, so what I want to show you is that maybe some of you did 19 as 15 plus 4. Right? 15 plus 4 is also 19, right? So what would happen if you split up the 19x as, say, 15x plus 4x, if I just switch the order here? Right, you're going to get the same answer. I'm going to see if I can squeeze that in here, if it's not too confusing. Right? So this is the way we did it, 4x plus 15x. But suppose we put the 15 in front here. In other words, if I just change the order, right? So what would happen? Well, I still have to factor by grouping, right? So this is still step 4 here. And what you would get is when you factor the GCF out of this, you would get a 5x, right? And when you divide, you get 2x plus 3. When you factor the GCF out of the 4x plus the 6, the GCF there is 2, so you factor out a 2, and you get 2x plus 3. Well, the 2x plus 3 is now our common factor, right? So when you factor out the 2x plus 3, you multiply by 5x plus 2. Right? And as you can see, this is the exact same answer we had right here. Right? And so either way is correct. So the point is, it doesn't matter if you switch the order here either. 15x plus 4x is the same as 4x plus 15x, right? Right. The factoring looks a little different here, the one I did in green, but in the end result will be the exact same thing. Right? It just might be in the opposite order, but as I mentioned many times already, the order doesn't matter when you're multiplying. Right? A times B is the same as B times A. 2 times 3 is the same as 3 times 2, and so on. Right? So in particular, 5x plus 2 times 2x plus 3 is the same as 2x plus 3 times 5x plus 2. Got it? All right. I guess it's your turn. You try one. Okay. 6x squared minus 13x minus 8. I'm going to factor that using the AC method. Okay. Let's see how this works, right? So the first step, well, A is 6, B is negative 13, and C is negative 8. Yeah, the ones we did earlier, probably a little bit easier because there were no negatives. Everything was positive, which is always nice. But the first step is to multiply A times C. So 6 times negative 8 is negative 48. Right? So what we're looking for here are two numbers whose product is negative 48 and whose sum is negative 13. So when we want them to add to a negative number, the bigger number should be negative, right? So let's start with 1 times negative 48. When we add those, 1 minus 48, we get negative 47, which is not correct. We're looking for negative 13, right? All right, so let's go on. Let's try 2 times negative 24 is negative 48. And 2 minus 24 is negative 22. Still no match. We divide by 3. Negative 48 divided by 3 is negative 16. And 3 minus 16 is negative 13. But that's our match, right? That's B. Okay, so yep, it's not prime, right? This will work. Step 3, oops, sorry, I didn't mean to do that in green. Step 3 is to split the middle term up, right? So in other words, the negative 13x you can write as 3x minus 16x, or you can do negative 16x plus 3x, either way. So let's do it this way, right? In fact, I'll do it over here on the right. So 6x squared minus 13x minus 8. If we split up the middle term, we get 6x squared plus 3x minus 16x minus 8. Minus 8 here, right? Okay. And now just factor by grouping. And that means we're going to split this up. The first two terms, you can factor out a 3x. And you're left with 2x plus 1. From the last two terms, you can factor out a negative 8. And you're left with 2x plus 1. So when you factor out the 2x plus 1, that's going to multiply 3x minus 8. And there's your answer, right? So 6x squared minus 13x minus 8 is just 2x plus 1 times 3x minus 8. Right? Or, if you prefer, 3x minus 8 times 2x plus 1. Again, order doesn't matter. Multiplication is commutative. Commutative is just a fancy word for order doesn't matter. Order does not matter, right? Sorry. Right. Anyways, yeah, so either answer is correct. So I hope that wasn't too bad. Again, right, here we only had three attempts, right? 3 tries before we got the correct pairing here. Again, sometimes it might be a lot longer than that, but in this case it was just three chances, 3 tries. Okay, here's another one for you to try. I don't think this is a particularly difficult one, other than the fact that there's also a y instead of just an x, right? So 4x squared minus 5xy minus 6y squared. Okay. Right. GCF is 1, as it usually is, although not always, but keep that in mind, right? So A is 4, B is negative 5, and C is negative 6. So your first step is always multiply A times C. So 4 times negative 6 is negative 24. Okay, so what 2 numbers multiply to negative 24 and add to negative 5? Again, let's go through the possibilities. All right, I know some of you might think this is obvious. Great. But for those of you that don't, let's just go through all the possible combinations here, right? So I'm going to start with 1 times negative 24, because the bigger number should be negative if you want to add to a negative, right? So 1 minus 24 is negative 23, which is no match. We're looking for negative 5. Okay. So let's go to 2 times negative 12. Sorry about that. 2 times negative 12. 2 minus 12 is negative 10, which is double, right? It's 2 times negative 5, but it has to match exactly. It's not negative 5. Okay, so if we divide by 3, we get negative 8. So 3 times negative 8 is negative 24, and 3 minus 8 is negative 5. Again, there's our match, right? Right. In particular here, it's 3xy minus 8xy is negative 5xy, right? So for our step 3 here, right, we leave the 4x squared and the 6y squared here, negative 6y squared, but we're going to take the middle term and split it up into these 2 terms down here in the lower left, right? The 3xy minus 8xy. So 4x squared plus 3xy minus 8xy, and then minus 6y squared. Okay. Why did I split that up like that? Well, now I have 1, 2, 3, 4 terms, and whenever you have 4 terms, you should always think about grouping. So we're going to factor this by grouping. Again, just take the first 2 and the last 2 separately. When you group the first 2 together, the GCF here is just x. So when you factor out the x, you're left with 4x plus 3y. And then from the last 2 terms, the negative 8xy minus 6y squared, well, the first one's a negative, so we'll factor out a negative. The 6 and the 8 have a common factor of 2, but they also both have a factor of y. So the GCF here will be negative 2y. So when you factor out the negative 2y, you get 4x plus 3y. Right? And now this should work because the 4x plus 3y is our common binomial factor, but we can factor out the 4x plus 3y. Right? And what does that multiply? The x minus 2y. And we're done. So that's the answer. Again, if you split this up in the opposite order, if you did the negative 8xy plus 3xy, you probably got the same answer, but in the opposite order. You got the x minus 2y first, followed by the 4x plus 3y. And as I mentioned many times, it's the same thing. Right? Order does not matter when you're multiplying. Okay, so that's how that one goes. Let's try another. Okay, next example. Factor 2u squared plus 5u minus 16. Okay, GCF is still 1, right? Because 5 is not divisible by 2, so we cannot factor out that 2 there. So that means A is 2, B is 5, C is negative 16. So in step 1, you multiply A times C. That's 2 times negative 16, and that's negative 32. So what two numbers multiply to negative 32, right? But they add to 5. So let's start with negative 1 times 32 is negative 32. Negative 1 plus, let me do it down here. Negative 1 plus 32 is 31. So that's not right because it doesn't equal 5. So divide by negative 2 and you get 16. So negative 2 plus 16 is 14. And 14 does not equal 5. So we move on to, well, it's not divisible by negative 3. So we can skip that one. We can divide by negative 4, right? And then we get 8. So negative 4 times 8 is negative 32. And negative 4 plus 8 is 4, which is not equal to 5. Okay. Notice we actually skipped 5 here. We have 14 is bigger than 5 and 4 is less than 5. And so that tells us that we're done, right? We skipped the negative 3 because that's not evenly divisible, right? Yeah, and in fact, there are no other possibilities, right? Because it's not divisible by negative 5 or negative 6 or negative 7, right? The next one you would try is negative 8 times 4. And that would give you a negative 4, which is the wrong sign. It's not even, it should be a positive 5, right? So we tried all the possibilities here. None of them work. So that means this is prime. Right? This one is not factorable. Well, specifically, it's not factorable over the rational numbers, right? But let's not get into that, right? It's not factorable or prime, either way. Okay. So yeah, right, and you can stop there. There's no, you don't need to go on to step 3 or step 4, right? There is no way to split the middle term up, right? There's no way to split this up into two terms that will factor correctly here, right? So, right, so this is why I think the AC method has a pretty big advantage here. This will tell you that it's prime fairly quickly. Okay? If you tried by the guess and check method, it probably took you a little bit longer. Maybe not that much longer, but a little bit longer. So the guess and check method really does not work very well when you're talking about factors that are prime. Or in this case, the trinomial that ends up being prime. Okay? Yeah. So again, I would highly suggest you ignore the guess and check method and focus on the AC method. All right, let's do another one. All right, see if you can factor 2x squared minus 10x minus 72. Right, so you can think A is 2, B is negative 10, C is negative 72, and A times C would be 2 times negative 72, which would be negative 144. Right, so what two numbers multiply to negative 144 and add to negative 10? Well, that could take you a while. Again, these are pretty big numbers here. But if you did that, you skipped one of the very crucial steps, right? Remember, the first thing is GCF. It's not 1 here. The GCF is 2. So you're better off factoring out that 2 first. Right? So once you factor out that 2, now you can factor by the AC method. But this should look even more familiar. We don't even need the AC method here because the leading coefficient here is just 1. So all we really need at this point are what two numbers multiply to negative 36 and add to negative 5. Well, if it's not obvious, let's go through the possibilities, right? It's either going to be 1 times negative 36, 2 times negative 18, positive 3 times negative 12, or positive 4 times negative 9, or 6 times negative 6, right? So when you add these up, you get negative 35, negative 16, negative 9, and there's our match, negative 5, right? Here we get 0. So the two numbers are 4 and 9. 4 and negative 9. Okay. So that's it. It turns out we did not even need the AC method here to do this. Right. Now, if you didn't factor out the 2 here, then sure, you used the AC method. But you are making it a lot harder on yourself if you did that, right? So always factor out the GCF first. It's true that up until now, the GCF was usually 1, right? But when it's not 1, you should factor it out first and save yourself the hassle, right? Now, incidentally, we could have factored this, right, without the 2, rather, by the AC method, even though it's not necessary, right? So let's use the AC method here anyways. And you'll see it takes a little bit longer, right? So here A is 1, B is negative 5, and C is negative 36, right? Again, don't forget the 2, right? That's still there. But we're going to focus on just factoring this over here, right? The x squared minus 5x minus 36. Okay, so what's A times C? It's 1 times negative 36, or just negative 36. So what two numbers multiply to negative 36, right, and add to the middle number, the negative 5? Right. Well, we just answered that, right? It's these two numbers here, the 4 and the negative 9, right? So here's where the AC method is a little bit different here. We have to split up the negative 5x, right, as positive 4x minus 9x. Right? And then we have to factor by grouping, which again, you've done many times, but let's go through it again. You factor out the x, and you get x plus 4. You factor out the negative 9, and you get x plus 4. So, right, factor out the x plus 4, and the other factor becomes, right, sorry about that, x minus 9. So x plus 4 times x minus 9. Now, don't forget to put the 2 back, right, because there was always a 2 in front here. Right. So And that's the same answer we got way up here. So sure, in this case, the shortcut, the one we learned last time, is probably easier than going through the AC method. But it's good to know that the AC method works anyways, even if A is 1, right? And, you know, when you're talking about x squared minus 5x minus 36, in this case, we're considering A to be 1. Right? If you go back to the original problem, then sure, A is 2. But that's because you forgot to factor out the 2 as the GCF. All right, so I hope that helps. All right, try this one. We want to factor 8 minus 2r minus 3r squared. Okay, first of all, this does look backwards again, right? And we've seen one in the previous video. What happens when it's backwards? You should probably just switch the order here. In this case, I'll put the negative 3r squared first, then the minus 2r, and then the plus 8. Okay. And not only that, because we have a negative, right, you could consider a to be negative 3. I would factor out the negative sign here, right? Factor it out as a negative 1, leaving you with positive 3r squared plus 2r minus 8. Again, you don't have to do that, but it does make it easier when a is already positive. Okay. All right. At this point, the GCF is 1. So a is 3, right? B is 2, and C is negative 8. So step 1, multiply A times C. That's 3 times negative 8. And we get negative 24. See, even I make mistakes. So what two numbers, right, have a product of negative 24, right, and a sum of, be careful, positive 2, right? It's not the negative 2 from the original problem. We already factored out the negative 1. So we want them to add to positive 2 now, right? So let's go through the list, right? We want negative 1 times 24, but that adds to 23, not 2. We could do negative 2 times 12. That adds to 10, not 2. We could do negative 3 times 8. Negative 3 plus 8 is 5. Still no match. You could do negative 4 times 6. Negative 4 plus 6 is 2. There's our match, right? So the two numbers are the negative 4 and the 6. So what that means is we're going to split up the 2r in the middle here. So save some space. And split that up as, keep the 3r squared, right? And keep the negative in front. Don't forget that. But the 2r is going to be negative 4r plus 6r minus 8. Again, if you did the positive first, the 6r minus 4r, that would be okay too. I'm going to do it this way, right? So now factor by grouping. When you split this up, you can factor out an r. So this becomes 3r minus 4. And for the last two terms, you can factor out a 2, and that becomes 3r minus 4. So you factor out the 3r minus 4, and you're left with r plus 2 as the other factor. And that's it. Again, don't forget the negative in front. You can think of it as a negative 1 times 3r minus 4 times r plus 2. That's an r. Yeah, so I hope that helps. Again, there's a lot of different ways you could write this. One way, of course, is just to change the order here. You can put the r plus 2 first, and then the 3r minus 4. So that's no problem. The other thing you could do is distribute the negative here. So you can do r plus 2 times 4 minus 3r. And of course, you can change the order here as well. So a lot of different ways you can write this. I guess let's do that as well. So this is 4 minus 3r times r plus 2, or even 2 plus r if you like. Right. But again, as a rule, I would factor out the negative sign first if the first term is negative. Right. Okay, so I hope that helps. Let's keep going. All right, we want to factor 6x squared minus 26x plus 50, minus 26xy plus 15y squared. Right. So yes, we have to worry about the y squared, but I think we did one like this earlier, and it just worked out perfectly, right? So let's start with the GCF. It is 1 here, because 26, even though it's divisible by 2, right, the 15 is not divisible by 2. And 15 is divisible by 3, but 26 is not divisible by 3. So yeah, GCF is 1. Okay, so that's unfortunate, because A is 6, B is negative 26, and C is 15. Right? So for my A times C, you get 6 times 15, right, which is 90. Right? So we're not 3 digits, we're only 2 digits, but we get a pretty big number here. Right? And so in step 2, we need to find two numbers whose product is 90. Right? That's the product. And we want the sum to be B, which is negative 26. Okay, so we know both numbers have to be negative. So let's start with negative 1 times negative 90. That's positive 90. And when we add them, negative 1 minus 90, we get negative 91. So that's not negative 26. No match there. Well, let's go on to negative 2 times negative 45. When you add those, you get negative 47. Still no match. When you divide by negative 3, you get negative 30, right? So negative 3 times negative 30 is positive 90. And negative 3 plus negative 30 is negative 33. Still no match. Let's see. Can we divide by negative 4? Nope, not evenly. Can we divide by negative 5? Yes. And I'm going to say negative 18, I think. So negative 5 plus negative 18 is negative 23, which is not negative 26. Right? And I think we can stop here, because we skipped negative 26, right? We went from a bigger number, or, well, yeah, a bigger number in absolute sense to a smaller number. And so there's no reason to go ahead and check any others, because they're just going to get smaller than this, right? So, yeah, I think we can do negative 6 times negative 15, but that's not going to work either, right? That's just negative 21. So you can see you're just getting further and further away. So there is no match here, right? This is going to be prime. Right? Yep, again, that doesn't always happen, but here it worked out. And again, you can stop here, right? You don't have to keep checking once you pass up that number that you're looking for. Right. I think there's only one other possibility, right? Negative 9 times 10 negative 9 times negative 10 is positive 90. Getting confused. And negative 9 plus negative 10 is negative 19, which is still not negative 26. So again, there's no match here, right? Right. So that exhausts all the possibilities. And so now we know for sure it's prime. Okay, try this one. 8x squared plus 28x plus 24. It should be a little bit easier because everything is positive. You don't have to worry about those negative signs. All right. And I hope you didn't do 8 times 24. I mean, you know, that's one way to do the problem, but you're going to get a pretty big number there. 192. So what two numbers multiply to 192 and add to 28? That's the sum. Yeah, that could take you a while. Right. But it's completely unnecessary because you forgot the GCF is not 1. It's not even 2 here. It's going to be 4. Okay. So can I erase the thing here? Yeah, so again, always check for the GCF first. The GCF is 4. So factor out the 4, and that leaves you with 2x squared plus 8x plus 6. Sorry, that's not right. It's 7x, right? Yep. Even I mess up on occasion. Yeah, 2x squared plus 7x plus 6. Okay, so we still have to try to factor this, right? So let's worry about just the 2x squared plus the 7x plus 6. Again, don't forget the 4 here. That will be part of the answer when we're done. All right, so yeah, so we can't go any further here. So now we have to use the AC method. A is 2, B is 7, and C is 6. So A times C is 2 times 6, which is 12. So we need two numbers that multiply to 12 and add to 7. You can try 1 and 12. Right? You can try 2 and 6, or 3 and 4. Right? So it's got to be the 3 and the 4. Right? 1 plus 12 is 13. That's not a match. 2 plus 6 is 8. And I did have 8 there by mistake, but it's a 7, right? So 8 is not a match. But 3 plus 4 is 7, and there's our match, right? So we're going to split up the middle term. The 7x becomes, well, it could be 3x plus 4x, or 4x plus 3x. It's up to you. Right? I'll do it this way. 2x squared plus 3x plus 4x plus 6. Now we can factor by grouping. So from the first two terms, you factor out the x. And from the last two terms, you can factor out a 2. So that leaves us with 2x plus 3 times x plus 2. Right. Oh, don't forget the 4. Right, there's a 4 in front. Right, so 4 times 2x plus 3 times x plus 2. Right, yeah. Yeah, so it's easy to forget the 4 if you ignore it. So sometimes I'll just keep the 4 here the whole time and just put brackets around everything. Right? It's probably the better way to do it because it is easy to forget that GCF there, right? Yeah, and I did this once before. I'll show you what happens if you change the order, right? If you did 2x squared plus 4x plus 3x plus 6, right? You're still factoring by grouping, but it's a little bit different now, right? You factor out the 2x and you get x plus 2. Here you factor out the 3 and you get x plus 2. So when you factor out the x plus 2, you get 2x plus 3. Right, same thing, just in the opposite order. And don't forget the 4 in front here, right? So, yeah, as I mentioned many times, when you change the order of the factors, it does not affect the answer. It just affects the appearance of the answer, right? Okay. Yeah, so again, GCF was 4. Factor that out first. And we still had to factor by grouping, but, using the AC method. But I'm thinking this was a pretty simple one. On the other hand, if you kept it as, A is 8 and C is 24, it's not going to be just these 3 combinations. You're probably going to get something like a dozen or so. It's just less pleasant when you have to go through a lot of those. All right, let's try another. Okay, so if you're up for a challenge, try this one. 9x cubed plus 32x squared y minus 16xy squared. Yeah, so this one's not quite so simple. All right, so first thing is to notice is that the GCF is not 1, although the 9, 32, and negative 16 only have a 1 in common, but everything has an x in it, right? There's an x here, there's an x here, there's an x here. So we should factor out that x first. So the GCF is just x. Okay, so that's the first step, factor out the x, and we're left with 9x squared plus 32xy minus 16y squared. Okay, right, now we don't have a choice. Now we have to use the AC method. I'll write it over here. A is 9, B is 32, and C is negative 16. Okay, so what we're looking for are 2 numbers that multiply to A times C. So 9 times negative 16 is negative 144. Okay, so pretty big number, 3 digits, but that sometimes happens, right? So what 2 numbers have a product of negative 144 and a sum of 32? Okay, so let's go through the list, right? We want it to add to a positive number, so the bigger number should be positive. So let's start with negative 1 and 144. When you add those up, you get 143. No match, not even close, right? So can we divide by negative 2? Sure, we get 72 for the other factor. And negative 2 plus 72 is 70, not 32. Again, not even close. What about negative 3? So 144 divided by negative 3 is positive 48. Right, I don't think I said that right. Negative 144, right, divided by negative 3 is positive 48. Okay. And negative 3 plus 48 is 45. Still no match. Can we do negative 4? Sure, I think 36. Negative 4 plus 36 is 32. We got it, right? There's our match. So not too bad, right? It took a while, but we got there. So it's not prime. All right. Yeah, I just want to check 36 times 4. Yeah, 144. So all right, so that works out. Now we have to split up the middle term, right? The 32xy is going to be negative 4xy plus 36xy. And I'll leave everything else. And yep, don't forget the x in front. That will still be there in the end. But now we have to factor this by grouping. So split up, I'm not going to go all the way here. Yep. Split up the first 2 terms and the last 2 terms and factor by grouping, right? So from the first 2 terms we can factor out, it looks like just an x. So we get 9x minus 4y. From the last 2 terms we can factor out, let's see, a y, but also a 4, it looks like. So 4y is the GCF, right? So when you divide 36xy by 4y, you get 9x. Negative 16y squared by 4y, you get negative 4y. So this is looking good because these two factors match. So we can factor out the 9x minus 4y, and that's going to multiply x plus 4y. And we're done. Right. Not a pleasant one. And just to remind you, if you put x times x plus 4y and then times 9x minus 4y, that's also correct. Again, the x should come first as the common monomial factor, the GCF. Right? Okay. One more, and then we'll move on. All right, try this one. Oh, sorry, I forgot the directions. Directions, of course, are to factor, and factor completely. 2d to the 4th plus 15d squared plus 28. Okay, right, GCF is 1. Okay, and a is 2, b is 15, c is 28. So a times c, 2 times 28 is 56. So we're looking for two numbers whose product is 56, right? And whose sum is 15. So that should be what they add to, right? Right. Can we even find such numbers? Well, it's not 1 in 56, right? It's not 2 times 28. Well, let's put the sums here, right? That's 30. Can we divide by 3? Nope, not evenly, right? You get 18.666, whatever, so we'll skip that one. Can you divide by 4? Yeah, 4 times 14, right, is 56. And 4 plus 14 is 18. Okay, still no match. Can you divide by 5? No. Can we divide by 6? I don't think so. Nope, just checking. Can we divide by 7? Yep, 56 divided by 7, oops, is 8. And 7 plus 8 is 15. Yep, there's our match, right? We wanted the sum to be 15. Okay, so the middle term here, the 15d squared, we can split up as 7d squared plus 8d squared. Right, so that's step 3. 2d squared plus 7d squared plus 8d squared plus 28. Oh, sorry. The first one here is not 2d squared, right? It's 2d to the power 4. So 2d to the power 4. Right? Yep, that's a 4. All right, now we just factor by grouping, right? Split this up. For the first two terms, you can factor out a d squared, and you're left with 2d squared plus 7. From the last two terms, you can factor out, I think, just a 4. Yep. So you factor out the 4, you get 2d squared plus 7. Right? And now you just factor out the 2d squared plus 7. And what does that multiply? D squared plus 4. And we're good. So that should do it. Again, I don't imagine they're going to be all that much harder than this one. Or the previous one wasn't that easy either because of all the x's and y's and the GCF. Right here, of course, the GCF was 1, so that made it a little bit easier. But that's it. Right? This should be enough practice. Hopefully enough to do the homework and the quizzes. So I hope you find it a little bit easier now anyways. Good luck.